Hello and welcome to the video lecture on projection of solids. So, let us see first what is a solid is. Solid is a three-dimensional object which has a definite length, breadth and height. To classify solids, we have four categories in our syllabus, that is pyramids, prisms, cone and a cylinder. So, basically pyramids and prisms are little similar and cone and cylinders are little similar. So, let us see some models which I have with me. So, I have a triangular pyramid. So, triangular pyramid will have a triangular base and then 3 slant edges and 3 triangular faces, and the point which is at the top is called as apex. Similarly, in a square pyramid, suppose we have a square pyramid, the base is a square, then it has got again 4 slant edges, 4 base edges of course because they are square, and an apex. So, we can classify this way. A pyramid could be a triangular one, square or a rectangular, pentagonal and hexagonal. So, we have another pyramid here which is pentagonal. So, the similarities between these two pyramids is the base, this is square and this is pentagon, and again it has got 5 slant edges, this has got 4 slant edges. Both have apex and the most important one is this triangular face. So, the square pyramid will have 4 triangular faces and the pentagonal pyramid will have 5 and the hexagonal will have 6 triangular faces, 6 slant edges and 6 base edges. Okay. Now, the next important terminology is the axis. Now, what an axis is? So, the axis is nothing but a imaginary line connects between the center of the base to the apex. So, it will be there in all the solids. So, basically we must know how to locate it in a view. For that we need to know what is the center of the different planes. So, that we will be discussing first. Before that, let me complete the introduction. So, pyramid we discussed different types of pyramids we have. Then prisms. Suppose if I take a prism, this is a pyramid, pentagonal pyramid. So, I have a pentagonal prism with me. So, what is the difference here? So, the difference between a pyramid and prism is the prism does not have an apex. So, what it has is, so it has a base similar to the pyramid, but it has a top face it also. So, base and the top face both are similar, connected by 5 lateral edges. So, whereas we call these edges as slant edges because they are slant, and in the prism we call them as a lateral edge because they are perpendicular to the base. Okay. So, in a pentagonal prism we have base pentagon, top face pentagon, both are similar and connected by 5 lateral edges because they are pentagonal prism. If it is a hexagonal prism, 6, square prism 4 and so on. And the second important thing here is this even has got an axis. So, axis will be from the center of the base to the center of the top face. Okay, it is an imaginary line. And the important difference between pyramid and prism is, pyramid has triangular faces as we discussed, pentagonal pyramid allow 5 triangular faces, 1, 2, 3, 4 and 5. So, here in a prism we do not have triangular faces, we have lateral face in the form of a rectangle. So, suppose it is a pentagonal prism, it will have 5 rectangular faces, okay, and if I show you a hexagonal prism, in hexagonal prism we have 6 rectangular faces. Okay. So, unlike in a pyramid we have triangular faces there, number of triangular faces equal to the plane. Okay. So, the sides of the plane. Now, in hexagonal prism we have a hexagon at the base, hexagon at the top face and 6 lateral edges, 6 lateral faces. The shape of the lateral face is rectangular. So, these are the important terminologies of prisms as well as the pyramids. Now, let me show you a cylinder, model of a cylinder. So, everyone knows a very familiar object. So, in a cylinder we have again 2 faces, base and the top both are circular, and it will have a curved surface, we do not have any edges on the surface. So, anyway when we deal with the projections I will let you explain that. And what is a cone is? So, cone is similar to the pyramid which will have an apex. I do not have a model with me, but we can imagine, suppose we have a apex here and it is connected to the base. So, it is called as a cone, and cone and pyramids are little similar because both have got apex. Prism and cylinders are little similar because both have base and top face. Okay. The difference is only cone and cylinder have curved surface, but pyramids and prisms have lateral edges and slant edges. Okay. And the pyramid has the triangular face in the lateral side and the prism has rectangular. So, let me start with projection of pyramids first, and before I move on to that, let me explain you some basic conditions in which the problems are mentioned. Okay. In the problems, generally, suppose if I take a pyramid is generally kept on horizontal plane, but how it is kept is a question. Okay. It could be kept on only two conditions or two different orientations. One is edge condition or corner condition. Okay. So, first we need to look for the base orientation, and we always start with the top view. Unlike in planes, in some plane problem we start with the front view, but in solids we always start with the top view, okay, in the first step. So, second step, third step, very similar to the plane we solve here. Okay. So, always we start with the top view. Now, the base orientations could be edge condition or corner condition. Only two conditions, either it has to be a corner or edge condition. Okay. And the second thing, this is the first part. Second part, the axis inclination, or it could be base inclination, or it could be slant edge or triangular or rectangular face inclination. Okay. These are the different conditions may be given for the rotation in the second step. So, in the first step what we do is we keep the solid, say pyramid, on SP and take two views. We start with the top view and we get the front view. That is the first condition. Okay. So, first step is over. In the second step, the second condition is used, how it is inclined to HP. Okay. All these are with respect to HP. All these conditions are with respect to HP. Let me explain you the different conditions. In the second step what happens is, suppose it is axis inclination, we rotate the front view, okay, with respect to the angle given to the HP. Okay. Then base inclination, sometimes this base inclination is given, okay, then base will be 0 initially. So, whatever inclination is given, we rotate for that inclination. Slant edge inclination, this is the slant edge. So, whenever slant edge is given, we have to go for corner condition because slant edge ends at a corner. So, corner condition we have to take here, corner condition in the first step, then rotate the front view this way. Okay. So, we can satisfy slant edge. Sometimes slant edge may be on HP, then we have to rotate completely such that the slant edge merge with the XY line. Okay. Then triangular face or rectangular face. Suppose in case of a pyramid, we have a triangular face. So, with respect to that, some inclination or it is on HP condition is given, we have to go for edge condition. Okay. Whenever triangular face is mentioned or rectangular face is mentioned in prisms, okay, then we have to go for edge condition. Okay. The third step or the third condition with respect to VP, so it could be axis or edge. So, with respect to VP. Okay. So, all these things you need to keep in mind. If you are able to understand and remember these conditions, then any problem could be solved very easily. Suppose if we go wrong in understanding the basic conditions, then the entire solution may go wrong. Okay. So, these conditions common for all the solids, whether it is a pyramid, whether it is a prism, whether it is a cone or it may be a cylinder. Okay. So, basically we start with the top view assuming that the solid is kept on SP. So, maybe it could be a prism. Okay. So, it is kept on HP, take the top view and front view, then this condition we check. What is the second condition? With respect to HP we need to satisfy. Then the front view is rotated, okay, and the top view is obtained, and for the third step the top view condition maybe axis inclination to VP or edge inclination to VP or something related with VP will be given. So, that we need to satisfy. So, we rotate the top view and obtain the final front view. That is how a problem on the solids is solved. Let us move into how to find out a center. Okay, for different planes, suppose it is a triangle, where is the center of the base? Because in a triangular pyramid or a triangular prism, we need to draw an axis. Axis is very important. Now, as I told you in the previous part, axis is the imaginary line drawn between the center of the base to the apex. Okay. So, what is the center of the base? Suppose the triangle, the center could be found by drawing the medians. So, median is a line drawn between the one of the vertices of a triangle to the midpoint of the opposite edge. So, similarly from this vertex to this midpoint and from this vertex to the opposite midpoint. So, this point is called as the center point, O or C, anything we can say, generally we say O. And suppose it is a rectangle or a square, the center is obtained by drawing two diagonals. So, this point is the center point. And if it is a pentagon, then we are supposed to draw perpendicular bisectors. Now, what do you mean by perpendicular bisector? The line drawn between the midpoint and to the opposite corner, which is always perpendicular. Now, if I draw the second perpendicular line, perpendicular bisector for this edge, it will intersect here and that is the center point. If I draw the third one also, it will pass through the same point. If I draw the fourth one also, it will pass through the same point, and the last one. So, all the perpendicular bisectors meet or intersect at a point which is called as the center, or it is one of the end point of the axis. And if it is a hexagon, it is very simple. It is like a square or a rectangle, draw diagonals. So, we will obtain the center point. So, this we need to remember very importantly, because without finding the center, it is difficult to go for the projections. So, let us solve a problem on square pyramid. Okay, this is a square pyramid. Let us see how it is mentioned in the question. A square pyramid, 30 mm sides of base, these sides are of 30 mm and 60 mm axis length. Axis is the imaginary line, anyway it is it has got a length 60 mm, rest on HP on one of its base corner. Okay, so this is the first condition given very clearly, is resting on a base corner. Draw the projection of the pyramid when the axis of the pyramid is inclined, HP at 30 and VP at 60. So, two axis inclinations are given. There is a square pyramid, 30 mm base, 60 mm axis length, resting on a corner of the base, and it is inclined 30 degree to VP and 60 degree to HP. 30 degree to HP and 60 degree to VP. So, axis is inclined, both conditions are with respect to the axis, and basically we need to understand it is a problem on corner condition, because corner is resting on HP. So, let us draw the XY line. When we solve this problem in the grid sheet, okay, the entire sheet is required. So, take the mid and draw an XY line, okay, and write X in the extreme left hand and Y comfortably at the right side. Okay, then write VP and HP, which represent the first angle projection, which we have dealt earlier. Okay, and when you are solving the problem in the solid edge, again in the sheet in the mid you draw the XY line, write X, Y, VP, HP representing the first angle projection. Okay, so let us draw the top view. So, it is kept at the corner condition and the top view is a square basically, and the square at a corner condition. So, let me draw quickly the top view. 30 mm line, we have to draw it 45 degrees to the XY line, okay, or to the grid lines, draw it 45 degree measuring 30 mm, then draw another 30 mm line perpendicular to this or at 45 degree, then similarly here and complete the square. Okay. So, this basically has all four sides equal to 30, okay, and the top view not only that much, when we see from the top we can see the slant edges. So, that is why for a square we are supposed to draw diagonals to obtain the center point, and this point when you see from the top, the first point what you see is the O apex, and where is O1? O1 is exactly below that and the same point it is, so bracket O1, O bracket O1. So, this is O, O1 is the base axis point. Then we have 4 corners, let me name them as A, B, C and D. So, A, B, C, D are the 4 base corners. So, this is the top view and all the 4 lines are 0.4 mm thick, because all the 4 lines are visible edges. So, these 4 edges AB, BC, CD and DA are the base edges, and the edges what lines what we can see here, OA, OB, OC and OD are nothing but OA, OB, OC and OD are slant edges. So, all the 8 edges are visible in the top view. Okay, so, all the 8 edges or all the 8 lines are here dark. Okay, so 0.4 mm thickness I am purposely drawn with the red color here. Next I am going for the projections. So, draw the projection lines 1, 2 and 3 and O1, let me mark O1 dash here. Okay, what is that O1 dash? O1 dash is nothing but the axis endpoint. Okay, the base point of the axis. Okay, I have kept like this. In the front view O1 dash is here. So, let me draw the axis here, because in the question axis height is given which is 60 mm. So, let me draw the axis for 60 mm, and when I draw a 60 mm line I am going to get O dash. So, O dash O1 dash is nothing but the axis which is having a length 60, which is given in the problem. So, every pyramid problem axis is must, and the axis is nothing but O1 dash to O dash, and here in every pyramid problem we are supposed to start with the front view with the axis, because we do not know the length of the slant edges. So, and it will not be given in the question. So, generally in the question base length and axis height will be given for every whether it is a pyramid problem or a prism problem. Okay. But in a prism problem it does not matter, because we have a lateral edge, we will discuss that later. Now, in a pyramid this axis is very important. Okay. After drawing the axis we can join, okay, we can join, because this is A dash, this is C dash and this point is B dash D dash. Okay, these are the 4 base corners which we can find on the XY line. So, this is A dash here, this is C dash and this point is B dash which is visible, and D dash is exactly behind which is not visible. So, let me draw the front view, this one edge, 2 slant edges, O dash A dash, O dash C dash, then O dash B dash, that has to be drawn. So, O dash B dash I am drawing here, and the base from this end to this end, this line is also dark. So, basically this will become the front view. So, I cannot represent the axis line here, because axis line is exactly overlapped by the edges. So, this line is also a thick line. So, whichever lines are drawn with red color here, this triangle and this line all are visible edges, all with the 0.4 mm thickness. So, this is common in all the pyramid or prism problems. Okay. Only thing is either it should be a corner condition problem or edge condition problem. Okay. So, in this problem try to understand it is a corner condition problem, because the corner is resting on HP and at the same time its axis is inclined to HP by 30 degree. Okay. Now, in the second step you are supposed to satisfy that condition. This front view you are supposed to rotate in such a way that this axis makes 30 degree with the HP, but at the same moment this C dash must be on XY line, edge on HP. So, 2 conditions we need to satisfy, that is why keeping this C dash on XY line we cannot draw the axis at 30 degree directly. So, what we do is we calculate base inclination. Now, presently the axis is making 90 degree with the XY line or with the HP, which has to be made 30 degree. That means, I need to rotate this particular solid or square pyramid by 60 degree, because already making 90 degree to SP. If I rotate 60 degree to the right, it will make 30 degree with the XY line, keeping this C dash point on xy line, okay, or on HP. So, what I do is I pick a point C dash here, and this base C dash A dash I draw at 60 degree. If I draw this at 60 degree, automatically you have to measure this length and draw the line at that length at an inclination 60. I will tell you why again. Okay. So, basically you mark this point which is O1 dash or B and also B dash D dash, and draw this axis which is perpendicular to the base O dash, okay, O1 dash to O dash, which is 60 mm and 90 degree to the base, okay. Now join A dash to O dash and O dash to C dash, okay. Now if I measure, this angle will be 30 degree. Why? Because, so this is the required condition in the problem, okay. We cannot satisfy together by keeping C dash on the xy line and also this axis at 30 degree is not possible. That is why what we do is we calculate the inclination of the base rather than the axis, because base I can draw if I know the inclination by keeping C dash on the xy line. So, I go for that, and this 60 degree is calculated by 90 minus 30, because axis inclination is 30 degree. So, base inclination will be 90 minus 30. Okay. So, this dimension I will delete, which is not required. Now, I go for the projections. Okay. Now, how to draw the obtain the top view. So, initially in the first step, this was the position, top view is drawn here, front view is drawn here. Now, this solid is rotated by 60 degree, axis is making 30 degree to HP, right. Now, what is the top view? So, what is the top view? So, that we are supposed to obtain now. To get the top view, first what we need to do is project the top view. So, these three lines we are supposed to project first. So, these are the three end projectors of D, AC, O1, 4 points are there, and B. Okay, let me mark one by one. So, A horizontal and A dash vertical will give me A. Similarly, B horizontal, B dash vertical will give me B. Then C horizontal, C dash vertical will give C, and D horizontal, D dash vertical will give D. And similarly, O1 dash is here and O dash is here. So, rest of the lines I will just delete. I am getting the 6 points. Which are the 6 points? A, B, C, D, the base corners, O and the O1. Okay. But anyway, O1 is not so important here, not O dash, sorry, O1. O1 are not so, O1 is not so important because the imaginary point. The important points are O, A, B, C, D. Okay. Now, let me tell you how to draw the top view. Okay. So, to draw the top view, there are certain rules we have to follow. So, they are very simple. I will just keep on explaining you. Okay. When it is inclined, so now you look at here, when it was kept on SP, the base edges were visible, slant edges were visible. But when I make it inclined, some portion of the solid may be invisible, okay, because it covers by the inclination of the solid. Okay. Now, how to understand that? When we, so it is inclined this way by 60 degree, okay. So, it is making 30 degree to SP. Now, when we see from the top, what is visible to us is the boundary. Whatever angle it is inclined, okay. So, the boundary means connecting the lines to the outermost points. For example, here boundary is O to D, O to B, O to B, A to B and A to D. So, this is called as boundary of the top view, okay, wherever it may be. So, here also we can see this is the boundary, ABCD was the boundary. Now, even though I rotate, this O will move out of the square and O is coming outside the ABCD. So, O is in the boundary and remaining points are connected, okay. Then what else is visible? When we see from here, this line is visible, O dash A dash. So, here it is OA. OA. So, it must be a dark line which is visible line, OA is visible. So, I repeat again, to obtain the top view, we have to look from the top, and what we see is the boundary of the solid and also the edge or face whichever is nearer to the observer. In this case, this edge O dash A dash is nearer to the observer, which we can really imagine here. Okay, so that has to be made dark. Now, what about the other two edges, that is DC and CB? Okay, so DC and CB are these edges. Okay, when it is inclined this way, we cannot see them. Okay, so they are supposed to be hidden. So, how shall I draw hidden line? A line, a small line with the same gap, again with the same gap and the line, a line with the same gap and so on. So, that is called as hidden edges or visible edges, and they are also having the same thickness equal to the visible edges. Okay, these are continuous lines with the 0.4 mm thickness, but these invisible edges also having same thickness 0.4 mm, but only their line type is different. Okay, they are hidden in the nature because they are not visible. Okay, so second step is completed. In other problems, this condition may be changed. The axis may be 30 degree or base could be 45 degree, or this axis inclination may be changed to 40 or 45 degree, or as I told you, mentioned in the beginning, the condition may be given with respect to the slant edge. Now, we can see slant edge is O dash C dash, which inclination we do not know or which is not given, or that could be given as a parameter in other problem. Okay, or the triangular surface. Suppose triangular surface conditions given the same problem, what we supposed to do is we have to go for the edge condition. Okay, so we will get the edge here, triangular face will be here, and that we can make inclined to HP and satisfy the given condition. Okay, such problems are like will be discussed later on. Okay, now we will come to the third step. What condition is given here is axis is inclined to SP by 30 and VP by 60. So, initially I will explain once again, this was our initial position, corner condition, okay, and then we rotated by 60 degree to obtain axis at 30 degree to SP. This is the present condition. Now, look at the axis, imagine the axis. Now, axis is exactly parallel to VP. How can we understand? OO1, OO1 is parallel to XY line, parallel to VP, okay. That has to be made 60 degree to VP. So, we have to rotate that by 60 degree either this way or this way. But important fact here is this axis has become apparent. This length is nothing but now apparent length, because it is the top view of the axis. This is the top view of the axis, because the axis length is 60, since this is rotated made inclined by 30 degree to SP, it has become 60 cos 30. But the given inclination is true. How we can understand the true inclination? You read the question, it is mentioned that axis is inclined. Okay, axis is inclined or in line is inclined means it is a true inclination. But the axis what we have here is apparent one, and we are going to rotate this particular view to satisfy the VP condition. So, we cannot go for 60 degree now, because 60 degree is the actual inclination, but the length what we have is apparent one. So, we need to do some construction here. So, that construction we called as beta construction, because from phi true inclination to VP, we convert that inclination to beta, which is apparent inclination to VP. Okay, so, since that condition or the construction is called as beta. So, what is beta construction is, we are supposed to consider the true length with the true inclination, draw a line at 60 degree, and mark O1 which is the true length of the axis, then draw a locus line, then measure the apparent length and from this point cut it on the locus. Here it will cut this way, because the inclinations are 30 and 60. Whenever theta and phi are 30 plus 60 90, beta automatically becomes 90 degree. Okay. So, beta is here only in this case 30 plus 60 it is 90, not in all cases. Since the inclination of the axis given with respect to the VP was the true, and this particular view is supposed to be redrawn now to the given condition with respect to VP, that is axis is inclined to VP at 60 degree, we have done the beta construction. So, I repeat again, the beta construction is nothing but the true length of the axis is taken at true inclination, because true inclination is given in the question. Okay. So, true length of the axis is taken at true inclination, then any one of the point we can draw the locus. So, purposely I have taken this as O2, okay, which is the true length, okay. Then drawn the locus line, and this particular length which is 60 cos 30 whatever, measure in the compass and cut it here. If you are solving the problem in the solid edge, dimension this value and cut a arc by center point from O to this. But in this particular problem, this construction is actually not required, because we know whenever theta plus phi is 90 degree, beta is also 90. Okay. So, this will be a straight line, but anyway I am explaining you the actual beta construction. Okay. So, we get a arc, just brushes of the locus point or O1 will be there. So, O1 is obtained here. Now, the important work here is to redraw this particular view here. So, how can we do that? So, look here, O1 is already drawn, I will make it dark because it is a edge OA. So, continue from O1 for this particular length, I am getting A. So, first I am extending this line, O1 I had there. So, continuing from O1 I will get A, okay. Then I am supposed to get B and D, which is easy. I use the compass, measure this AD or AB length, and from A I cut here and B I cut here, okay, which is on this line. So, I easily get on this line, because that line I have already there, this line is perpendicular to this, only thing is I need to measure this length and cut it here. So, it is B and D. Now, where is C? C is at this distance on the axis line. So, this is C. So, C to O is here. Now, as it is connected here, same way we shall connect in the top view which we are redrawing here or reproducing. Okay. And this is going to be the hidden edges. These are the hidden edges. Okay. So, this is the rotation of the top view. Okay. Actual the rotation was axis is inclined to 60 degree, but the apparent axis will be at 90 degree, or the apparent inclination is 90 degree, that is why. And one more thing is, we have kept apex closer to the xy line or VP, that could be taken in the other way. So, we have rotated this way 30 degree and rotated this way, okay, such that the apex is nearer to the vertical plane and the base is nearer to the observer. This could be other way also, 30 degree to HP, then this way also we could rotate, apex is nearer to the observer and base is nearer to the vertical plane or VP. Okay. So, that is not mentioned which has to be nearer to the observer, we ourselves assumed that base is nearer to the observer, apex is nearer to the xy line, or that is VP. Now, let me complete the final front view. To complete the final front view, what I am supposed to do is project the front view first, that is projecting O dash, and this O I will get O dash. So, one by one the points are projected, we have only 5 points here, including O1 dash 6 points. Okay, let me project O dash first, O from here. Now, A dash and A is here, so it is already here, it is A dash. C dash is on the xy line and C is here, so this point itself is C dash. So, on this point we have, on this line we have 4 points, O, C, A and O1. So, O dash, A dash and C dash on the respective horizontal line. Now, let me go for B dash, D dash. I draw a horizontal line from B dash, D dash and vertical line from B and D, where I get D dash and I get B dash. So, I have got the 5 points which are important: O dash, A dash, B dash, C dash and D dash. And O1 dash also I can mark now. O1 dash is here and it is on this line, but anyway it is not so important before I complete the view. Okay. Now to complete this view, as I mentioned you earlier, the 3 rules we need to keep it in mind. The first thing is, when it is rotated this way, what is the front view? Now observer will be here and looking at the base, because the base is nearer to the observer. In this view, base will be visible to the observer. So I can connect before that I can, so however it is inclined, so the boundary will be always visible. So when it was kept on SP, so this was the boundary. So this was the boundary and this is the visible edge because it is nearer to the observer. So in this view it is same, and when we projected the top view, okay, so this was the boundary OD AB and the visible edge is nearer to the observer. Now it is rotated this way, okay, so again we have certain boundary. So boundary is nothing but connecting the outermost points. So let me connect the outermost points, which are O dash to D dash, D dash to C dash, C dash to B dash and O dash to B dash. So this is the outermost boundary when it is rotated this way. So this is the outermost boundary and the base is visible to the observer. So I am supposed to join O dash to D dash, D dash to A dash to B dash. Okay, these 2 edges are visible because I can see AD and AB, AD and AB, which are very nearer to the observer, must be seen, and also this A, point A is also, or OA is also visible. So how can I understand? I repeat again, to obtain this view or this view. So one thing we need to keep in mind, that the boundary is always visible. Okay, so what do you mean by boundary? I told you. Okay, for this view, connecting the outermost point is a boundary. OD AB is the boundary, back to O. Here O dash, D dash, C dash, B dash and O dash is a boundary. Then what else is visible? That is nearer to the observer. In this view, this was nearer to the observer, so this was continuous. These 2 edges are behind or in the bottom side, we cannot see, so they are invisible. And for this view, this is the boundary connecting the outermost points, and what else is visible is this edge and this edge. How can we understand, or because we may not be having a model with us when we solve the problem. So how can we understand is from this view. Okay, look at this view. So for this view, observer will be here and what is visible to him is AB, DA and OA. So these edges are nearer to the observer, so they will become visible in the front view. So they are D dash, A dash, A dash, B dash and O dash, A dash. Only one edge is remaining to be drawn, and that is O dash to C dash. Okay, because we have drawn 4 base edges, 3 slant edges OA, OB and OD, 1 slant edge is remaining, that is O dash to C dash. Okay, so till O dash to A dash is a visible edge, but O dash to C dash, which comes in the backside, which is not visible, so I have to make this particular line as invisible. So again there is an axis between O dash to O1 dash, but I cannot represent it because O dash C dash is overlapping the axis. So this is the complete projection of a square pyramid when it is resting on SP with a base corner and axis is inclined 30 degree to SP and 60 degree to VP. Axis is inclined, but the apparent axis is 90 degree to VP, and at that particular situation this is the front view when the base is nearer to the observer. Same problem we can modify with base is nearer to vertical plane or apex is nearer to the observer, then this base cannot be visible, rather O dash C dash may be visible there. Okay, so this is how the problem can be modified. On any problem on pyramids are for these kind of conditions are solved in the similar way. Let us solve another problem on hexagonal pyramid, that is problem number 4 from the question bank. I will read out the problem. A hexagonal pyramid, 25 mm sides and axis 40, as I mentioned always side and axis height will be given. Rest on SP on its base such that one of the triangular face is perpendicular to SP. I am coming to the second criteria of conditions given with respect to SP is triangular face perpendicular to SP and parallel to VP and nearer to VP. Hexagonal base and 6 slant edges and an apex. So basically it will have 6 corners A, B, C, D, E, F, okay, and O and O1, which is the endpoints of the axis, and 6 triangular faces. Now, in this particular problem, the condition given with respect to SP is the triangular face. So, I told you in the beginning, when your triangular face condition is given, we have to go for edge condition in the first top view. If it is the condition given with respect to the slant edge, we have to go for corner condition. So, this is a problem on triangular face. So, we have to go for edge condition. And what condition is given? This triangular face is perpendicular to HP, means this way, and it is parallel to VP. So, I have to rotate this way and nearer to VP. This particular triangular face perpendicular to SP, parallel to VP, this is the vertical plane, parallel to VP and nearer to VP. That means, this particular portion is nearer to the observer. So, very clearly the problem is mentioned. Let us see how to solve. As I told you, we solve this problem again in 3 steps. First step, we keep the solid on the SP and we start with the top view and project the front view. And the top view, when we start, it should be a edge condition, because the problem given is with respect to the triangular face. So, let me draw the hexagon now. To draw an hexagon, we know the easiest method is draw a circle of radius 25 mm, because the sides having length 25. Okay, it is a edge condition problem. So, let me draw a vertical diameter here, and from these 2 points the radius I will measure and cut both sides from this point, both sides from this point. So, I get 4 points here, and now I can draw or obtain a hexagon at edge condition 1, 2, 3, 4, 5 and 6. So, if I name them A, B, C, D, E and F. So, this circle is not at all required, even though we can have it there, okay, although we can just erase them. And now to get the axis endpoints, as I mentioned in the beginning, draw diagonals, and these diagonals are dark as well, O bracket O1. So, this is the complete top view. This dimension I can write in aligned dimensioning method 25 mm, okay, and again we can have a look how the top view is obtained. It is the edge condition problem, and the top view is hexagon, and all the edges, slant edges OA, OB are visible, OA, OB, OC, OD, OE, OF. Okay. So, boundary is A, B, C, D, E, F, and from the top when we see, all the slant edges are visible. So, all these lines are 0.4 mm thick, which are visible. Now, let me project the front view. Draw 3 projection lines to the XY line. So, this is O1 dash, which is very important for us, because axis height is given, which is 40 mm. I go for the axis. So, this is the axis line type, a lengthy line and a small line, and this dimension if I draw, which is 40 mm, 40 mm is the length of the axis. I obtain O dash, and after I draw O dash, I can draw the front view. Join O dash to this point is when we see from the front, B dash is visible and A dash is not visible. Similarly, here D dash is visible and E dash is not visible, and here C dash is visible, F dash is not visible, and join O dash to D dash, join O dash to D dash, and this is the base, and also in the similar previous problem, this is also an visible edge. Okay. So, it is like this. So, what is the front view? This line as well as this line. Okay. It is a edge condition. Okay. So, we have these 2 edges together, this line, okay, O dash D dash and O dash E dash comes like together, and similarly these 2 lines comes together, O dash B dash and O dash A dash, and this is the line O dash C dash, O dash F dash is exactly backside. But anyway, this line is visible. So, this is the boundary and this is the visible edge which is nearer to the observer. So, the first step is complete. Okay. In the second step, it is at the edge condition. Okay. This is the first step kept on HP, drawn the top view and front view. Now, this particular triangular face, which is the triangular face? This one, ODE, ODE, OD is the triangular face. Okay. This one I am going to make perpendicular to HP, that is the given condition. One of the triangular face is perpendicular to HP. So, now it is not perpendicular, it is inclined to SP. I rotate this way. Okay. Or in the sketching here, what I supposed to do is measure this length D dash O dash and draw a straight line. D dash E dash. So, this particular line make it straight perpendicular to HP. Okay. Then how to obtain this point? Measure this length in the compass and cut an arc here. Similarly, measure a length from O dash to B dash and cut an arc here. So, we will get B dash A dash. Just join them. Just join them. Then mark this point which is the midpoint of this line, C dash F dash, also O1 dash, and join this line. So, this particular view is redrawn here, okay, same view, these two views are identically same, and this particular edge which is representing ODE, the triangular face, perpendicular to HP. So, this is perpendicular to HP, 90 degree to HP. Now, let me obtain the top view as we discussed in the previous problem. So, draw the projection lines. I have F projection, A and E projection line, then I have B and D and C horizontal as well as O horizontal. Then I project from the top ODE which is perpendicular, so it is on the same line. So, I go for O here, E here and D here. So, I will get 3 points on the same vertical line, because O dash, D dash, E dash is 90 degree or vertical line. So, I get O here, D on this point and E is on this line. Okay. Then F and C, so F and C will be here, C is here and F here, and the last one is A and B. So, A horizontal and A dash vertical, B horizontal, B dash vertical. So, I am getting all the points starting from A, B, C, D, E, F, and to obtain this top view again I have to follow the same rule. Okay, draw the boundary first. So, it is easy to recognize the boundary here. Join the outermost points this way. This is the boundary. Now, let us discuss what are the visible edges. Okay. So, this was the triangular face ODE perpendicular to HP. This is the position. And when you see from the top now, okay, when you see from the top now, okay, this is perpendicular to the camera or to the SP if I see in this way. Okay. Then in the top view everything is visible. Okay. This line is also visible, this line is also visible. That is very important. This is the speciality of only this particular problem. So, I have to join all the lines. Which are those lines? Those lines are nothing but O to A, O dash A dash and O to B. Okay. When it is perpendicular to SP, OA and OB are visible to the observer. Now, this is C and this is F, C dash F dash, O dash to C dash, O dash to F dash. Which are those? OC and OF, that is also visible. So, I go for OC and OF. Okay. Now, look at the view, all edges are drawn. I can see all the 6 base edges A, B, C, D, E, F and OA, OB, OC, OD, OE, OF. All the 12 edges are visible. This is the speciality of this particular problem. Okay. All the 12 edges. 6 base edges, 6 slant edges, all are visible, because it is a particular condition wherein the triangular face is perpendicular to HP. If this was inclined more, then some portion of the solid could be invisible. Okay. So, the remaining part is drawing an axis, that is O1 dash is here, this part of the line is axis. Okay. Nothing is overlapped on that. So, I can draw an axis here which completes the top view. Now, in the third step, with respect to VP, what is mentioned is this particular edge which is perpendicular to HP, that is ODE, O dash D dash E dash here, and it is ODE here, which is parallel to VP. What do you mean by parallel to VP? Parallel to VP means parallel to XY line in the top view. Okay, parallel to VP and nearer to it. Okay, so I have to rotate this way. This was the first step. Second step, third step is I have to rotate by 90 degree, because I have to make this particular triangular face parallel to VP and nearer to VP. This view has to be redrawn by keeping ODE parallel to XY line or VP, and so doing this view. So, first what I do is I go for ODE, I draw a line here, I draw this line, okay, center is O and 2 points are D and E. I have to reproduce or redraw this particular view there, okay, by keeping ODE parallel to XY or parallel to VP. Okay. Now, how shall I obtain other points? Okay, it is easy, can measure EF which is equal to DC, and I cut here, from D I cut here, this length I cut from here and here, then the cross distance D to F and C to E to C are same. So, I measure any one distance D to F, and D to F I cut here, and C to E I cut here. So, this is C and this is F. Okay. Now, similarly A and B. Okay. So, I can again measure FA and BC, from F I cut here and C I cut here. One is from F it is A and from C it is B. So, one distance I have cut here which is FA and BC, then I can go for cross distance C to A and F to B. So, C to A and F to B. Okay. So, I get other 2 points. Now, just join them. Just join them. Okay. So, O is here, I shall join O to F, O to A, O to B and O to C. So, this is how I can reproduce the entire view by just cutting the arcs. Okay. So, now to obtain the final view, so let me project O dash and O. First always mark O dash by projecting horizontal and vertical. Now, we can go one by one. Okay. So, like A and B, A dash B dash, project horizontally. Where is A dash B dash? AE, this together. Okay. So, this is A dash, this is B dash. Okay. A, B are projected vertically, A dash, B dash projected horizontal. Similarly, C and F, I go for C and F. So, F is here, F dash, C is here, C dash. So, I get C dash and F dash. Last one is D dash and E dash, which is already done actually, because AE and BD are on the straight lines. Okay. So, which is already done, I am just writing the point names here, which is E dash and this is D dash. So, I have obtained all the 6 plus 1 7 points there. Okay. O1 I am not going to mark right now, okay, because O1 is not a particular corner. Okay. These are the 6 base corner and this is apex. Apex is a visible corner. So, I shall draw the boundary. So, it is easy to understand the boundary which connects the outermost points. So, this is the boundary, okay, which connects the outermost point. Now, the question is what else is visible? It is easy to understand. Look at this region which is nearer to the observer. Look at this region. Okay. So, I am not showing the model because in the examination or any time you may not be having the model. Try to understand what is visible by looking at the top view. Okay. In this particular front view, observer is here to look at the view. So, what is nearer to him? Basically AB is very nearer to him. So, directly you can make A dash B dash visible. Okay. Then next, AF is partly nearer. So, definitely it is visible. BC is definitely visible. Okay. These two lines are nothing but OA and OB, that is also visible. So, this is how I can understand which are the visible edge in the final front view in any solid problem. Okay. Look at the region, the nearer to the observer. Okay. And one more thing, this is apex is away, base is nearer. That way also you can understand. Apex is here, base is here. So, entire base is always visible, whether it is a pyramid or it is a prism or anything. It could be a cylinder or it could be a cone also. The base is visible or nearer to the observer, then it will be 100% visible in the final view. Okay. So, OA and OB is also visible because A and B are very close, OA dash A dash. Now, you have a look on the model. So, it is perpendicular to HP and parallel to VP, and this is the view which we have obtained from the front. Okay. So, this is the front view, observer is here. So, base is 100% visible, that is why, and these are the two lines OB and OA are visible. Okay. Remaining there are edges which are invisible. So, they are O dash E dash. So, I have to make them hidden. Okay, hidden. And the last, to complete the problem, I am supposed to draw the axis. So, here this is the axis O dash O1 dash. I am supposed to draw it here. I will go with red color. Okay, this was O1. So, I projected O1 here, projected O1 dash here. This is O1 dash. Okay, that is O1 dash, and this particular part of the line is the axis. So, I must take axis line type and draw a line this way. So, I can complete the projections by drawing an axis here which is having this length, and O1 you project already is on the vertical line, O1 dash is here, you will get O1 dash, O1 dash to O dash is the clear axis which could have a thickness 0.25 mm. Okay, this is, and all the visible and invisible edges are 0.4 mm thick.